Hello beautiful people and welcome back to my class. My name is Davarian Pratama. I'm from University of 11 Maret from Math Education. So today I will explain you about one of the material in math, which is about set. So let's get check into it. So what is set? Like the definition of set. Set is a collection of things that have same common property. So keep in mind this. So you have two things. First, it must have a collection of things. Second, it has same common property. For the example, the things that can be worn like this, like for the example, jacket, shirt, t-shirt, then glasses, shoe, hat, and other things. That thing is the collection of things, but they also have same common property that differentiate with other, which is that things can be worn by us, like a jacket, like that. It different something with other, so that's why they become a set, a collection of things that have same common property. And this example can also be used in our finger. For the example, our finger have five. We have thumb, we have index finger, middle finger, and so on. We have five fingers, and that is a collection of things, and they have all same common property, which is our finger. That's why they are set. And the easiest example is you can just also pick a random number. For example, 6, 12, 2003. All of them is like three random numbers, but they also have same common property, which is number that are randomly picked by us. So that's why they have same common property. So that's why the three of them can become a set. Next, we have the element of set. There are three main elements of set, which is a bracket, an element, and a comma. What is bracket? Bracket are something, especially curly bracket in the set. Curly bracket is a thing that separate element inside of the set and outside of set. That's why we use bracket in the beginning and the end of the set. Like that, next is element. Element are the main component of the set because it's the element or it's the member of a set. And next is comma. Comma are something that different or separate every other element inside of the set. Like 3, 9, 9, 3, 6, 91, all of them are different elements. So that's why we use comma to separate 3 and 6. So it's not become the ambiguous. And there are some more explanation. First, the bracket that are used in the set are curly bracket, that's sometimes called set bracket or the braces. The next, we also have the three dots are called ellipses, that mean continue on. So in an infinite set, like for the example 3, 6, 91 and ellipses, that means that that set is not just end at 91, but they just goes on and continue until infinity. So that's why we use this ellipsis, because that means continue on. But there are also some cases that use ellipsis but in the middle of the set. For example, in the last, that in this case it is a finite set, which is there are 26 letters and alphabetics A, B, C, D, E, just goes on until Z. That set, instead of we write all of the member inside of the alphabetical letters, which is very large, we can use ellipses in the middle of the set. So that's why we can still write all the members, but instead of writing all, we can use ellipses in the middle of it, and then we write it again the last member or the last element inside of the set, X, Y, and Z. That's why we can use ellipses in the finite set. Next, we have ways of defining a set. First way is list all the elements. So we can just define a set or naming a set by list all the elements inside of it, which is 1, 2, 3, 4, 5, 6. This is the just easiest way to defining a set. Next is state the common property that it has. This is our second ways to define a set. For the example, A is an integer number that higher than 0. All of the number that have that properties, which is A is an integer number that higher than 0, is the element of that set. That's why we can define that set by just defining or just stating the common property that it has. Like for the example 1, 2, 3, 4, 5, 6 and goes on, all of them is just integer number and all of them is higher than 0. That's why we can defining that set in the first example by just stating the properties. And the last is describe its properties using set builder notation. So if you realize that our second way is to defining a set, we are use our language, we use English language. But in the third ways, we are using mathematical ways. We use mathematical symbol, we use mathematical element, like that. That's why we can describe our properties, but instead of with language, with English language, with like number higher than 0, we can just use this sample in math. So that's why this the third ways of defining set is most commonly used in math and most commonly used by other mathematicians. The next is the example of number sets. We already explained some number for some example in our life, like our real life. But there are also some example of the number because we talk about math, of course. We always talk about number. For the example, set of the even number, which is -4, -2. We know that even number is the number that can be divided by 2. Then we also have set of the odd numbers, which is the number that can be divided by 2. And we also have set of prime numbers, which is number that only can be divided by 1 and itself, and just goes on. There are so many number sets that we can find in the math. But there are actually some like a greater set, like a grid set that inside of it is just all of the number that we know right now. For the example, natural number. Natural number is just number that starts from 1 goes on infinity. That's natural number is just our number that commonly used in real life, like 1, 2, 3, 4, 5, and goes on. The next is integer number. Integer number are number that there are no decimal behind of that. For example, like 1, -1, -2, minus infinity, 0, and something like that. We know that minus doesn't really happen in real life, since we don't really have -2 things or -7 things. So that's why they call integer, not the natural number. Then we have our rational number, which is the number that can be described or can be defined by a over b. For the example, like 2/7, 4/5, 1/2, all of them is part of rational number. Then we have real number. Real number are just then all the number like rational number, but also they add the number that can be defined by a over b. For the example, pi number, Euler number. That number is just goes on the number behind the comma is just goes on until infinity. That's why they can be defined by a over b, and that's why they called irrational number, but they still part of real number. The next is imaginary number. Imaginary number are just number that doesn't really exist in our world. For the example is I number, which is square root of -1. That square root of -1 is just impossible to exist in our real life. But that I number is actually exists in some mathematical theory or mathematical ways that create more and more ways that we understand a lot of things about math. That's why we call that imaginary number and just part of the set number. And lastly, we have complex number. Complex number is just combination of all real number and all imaginary number, are just all the number that we know right now is the part of the complex number. And we don't know that this number set will be growth over and over again, since we know math it will always grow, it will always find something new in our life. So that's why I believe that this set can be more wider again in the future. Okay, next is why are sets are important? This is a very fundamental question why we learn about set. So this is sets are the fundamental property of math. We know sets by themselves seem pretty pointless. Like we know that everyone in the elementary grade school must know about set. Like even though we don't teach them about set, they we know about grouping something that have same common property. That's why we don't actually really need to study or to learn about set. But it's only when we apply set in a different situation do they become the powerful building block of math that they are. So in this time, instead of we learn sets by itself, like we just learn about sets itself, we can learn anything. But if we just use set in the other mathematical branch, that set will become very useful for that branch. For the example, calculus. We already know that calculus work with a real number, and if we use imaginary number on calculus, that calculus some theory or some rules in the calculus can be worked with imaginary number. So that's why we learn set, because if we learn set, we can know that there are real number that can only be worked with calculus. But if we don't work with real number, or we just work with imaginary number, because we don't learn about sets, the calculus can be worked because there are some rules like that. And this goes everything also with other mathematical branch, for example number theory and geometry. All of them need a correct number set to work with. So without the correct number set, they can be worked efficiently. That's why we must learn set, and we apply set in different situations and different mathematical branches. That's why sets are very important to learn. Next, we talk about types and operation of set. Okay, let's talk about types of set first. First, we have empty set, which is the set that has no element inside of it. Just as I mentioned, in the set, we need at least something inside. We can have one thing, two things, three things, or just nothing. So as long as you have things, even though it's nothing, it can't be set. So that's why the empty set exists. Next is singleton set, with the set which has only have one element. We also have equal set, which is two sets that have same members. For example, 1, 2, 5, and B is equal to 2, 5, 1. Both A and B have 1, 2, and 5 as their members, so that's why they are just similar. They not only have same amount of the element, they also have the very similar amount of elements, 1, 2, and 5. That's why we can say set A is equal to set B. The next we have finite set. Finite set is the set that has limited number of elements. For the example, A is equal to 1, 2, 3, 4. We know that 1, 2, 3, 4 only 4 number. That's why they are very limited. They are finite set. The next is infinite set. Infinite set is the set that has an infinite number of elements. For the example, A is equal to X is the set of all whole number. We know that all whole number is just integer number, and integer number has unlimited number inside of it. That's why we call it infinite set. Next, we have subset. A set A is said to be a subset of B if each element of A is also an element of B. For the example, if A is equal to 1, 2, B is equal to 1, 2, 3, 4, because 1 and 2 is all of the element of A, and 1 and 2 also conclude in B, set B, it can be said that A is subset to B because of all of element of A is consist in element of B2. The next is universal set. A set which consists of all elements of other sets present in a Venn diagram. For the example, if A is 1, 2, B is 2 and 3, the universal set here will be universal is equal to 1, 2, 3 because there are just all that number inside of that set, which is 1, 2, and 3. That's why universal set is 1, 2, 3. After we talk about types, let's talk about operation of set, because in some way we need operation of set. First, we have union of set, that's symbolized by U. If two sets A and B are given, then the union of A and B is equal to the set that contains all the elements present in set A and B. For the example, if A is equal to 1, 2, 3, 4, B is equal to 6, 7, then A union B is 1, 2, 3, 4, 5, 6, 7. The simplify to this is we just combine the element inside of A and B sets. So we have the union of the sets, which is symbolized by U. The next is intersection. If given two sets A and B, then intersection of A and B is subset of the universal set O, which consists of the same element as A and B. So in intersection, we just use the same element in set of A and B. For the example, if A has 1, 2, 3, B have 3, 4, 5, both A and B have the same element, which is 3. That's why the intersection of A and B, which is symbolized by U overturn, is 3, because 3 is just the element that both have A and B have. Next is the complement of set. Complement of set. If a U is universal set and X is any subset of U, then the complement of X is the set of all elements of the set U a part of the element of X. This is very difficult, but there actually have the simple way to describe it. For the example, if U is 1, 2, 3, 4, 5, 6, 7, 8, but A is only 1, 2, 5, 6, which is not all of the U. So we can actually say that A complement or A complement of A is the element outside of A but still inside of U. For the example, in the example, A is only 1, 2, 5, 6, but U have 3, have 4, have 7, have 8. That's why 3, 4, 7, 8, all of them are the complement set of A or A complement. The next is difference of set. If there are two sets A and B, and then the difference of the two sets and B is equal to sets which consist of element present in A but not in B, it can be represented by A minus B. For the example, A is equal to 1, 2, 3, 4, 5, 6, 7, but B is 6 and 7 only, then A minus B is just the element of A consists in A but not in B, because we already minus all the element inside of B. For the example, 6 and 7 are consist in A, but 6 and 7 also consist in B. So that's why A minus B is just the member of A, element inside of A, but minus the element that also B have, which is 6 and 7. So that's why A minus B is just 1, 2, 3, 4, and 5. I think that's all material that I have to say today. Thank you for watching until the end of the video. I hope you guys understand about it. And I'm sorry if there is some grammatical mistake or some mistake that I say. I'm so sorry. And if you have any question, you can just comment below. That's it for me. See you. Stay rational and peace.